So my name is Tim Deep. I'm the customer success manager for DCCap, and DCCap is the parent company of QA Touch. QA Touch is just one of the products that we have. But DCCap, we're a digital agency. We do a lot with e-commerce, websites, implementations, and integrations with ERP systems. And it's been great. And it's a pleasure hosting for this event. So I think I did do the last one, and just last week I had a bigger event for DCCap. So I'm always there in terms of just trying to just create more awareness for each of the communities. So for this QA Touch community, it's more specific for QA Touch, more for the QA test management system. So and then for today, you're going to be hearing from Michael shortly after this, but then later on we'll have Sneha. She'll be talking about distributed testing as well. So, and if you guys want to do any type of hashtags or sharing on social media, you'll see on the bottom left, the hashtag will be QA_Touch_learning. It's just so everybody could be engaged, and you can see all the different comments within the ecosystem. And yeah, there's also a poll on the bottom. If you guys could fill that out. We also have questions as well. So since this is a webinar format, you'll only be the only people that will be able to share their screens will be Michael and Sneha and myself. But if you guys have any questions at all, feel free to chat and submit your questions on the Q&A portion. So Michael, he'll be talking about testing deep and shallow. And just throughout the whole presentation that he has, if you have any questions at all, just feel free to submit it, and I'll be the one to kind of moderate. And if there's any questions, I'll stop Michael, and he'll be able to answer them. But
well, Tim, yeah, right now, I'd appreciate that. In fact, if you were to interrupt me at the moment the question comes up. So
for sure. Yeah. So once you're ready to go with yours, you could share your screen, and if you ever do see my video pop back up, then you'll know that okay, there might be a question that's coming your way. Okay.
All right.
So I'll go ahead and stop my screen, and you could share yours.
Okay. So James Bach and I, we're the authors of Rapid Software Testing, which is a methodology and a set of classes on how to do software testing in a way that is super fast, super inexpensive, super credible, which still completely fulfills the mission. That's what rapid software testing is all about. And one of the things that happens when people hear that term is that they just think it means rapid software testing means fast. And it doesn't. Because fast without any other consideration is probably not going to be helpful. You can drive across town at 250 kilometers an hour if you want, but you're not going to get very far very quickly, and you're going to get into trouble fairly quickly if you choose to do that. So it's not just about the speed, it's also about the efficacy of it and the credibility of it, because as a tester, your credibility and your reputation mean everything. So it's not just about fast testing, it's about good testing. And then we came to this thing that I'd like to put in front of you. How do we characterize good and bad science? Well, people talk about valid research as good science, or they talk about junk science as bad science. They talk about unsupported theories, or they talk about thorough analysis, or they talk about deep investigation, or they talk about pseudoscience. They talk about the reliability of data, reliable or unreliable data. So what's interesting is when people talk about testing, we don't see the same kinds of notions, the same kinds of descriptions of testing. Testing is just kind of testing. So in your mind, I'd like to ask you just for a sec to think in terms of how you characterize good and bad testing, or think of the words that we put in front of testing. Do we have any vocabulary for it other than good and bad, and what would those mean? Well, let me get you to do that just for a few seconds. Think about words that we put in front of testing. Now, James and I did this ourselves, and it seemed to us that most of the time, people thought in terms of words that go in front of testing: load testing, or reliability testing, or sanity testing, or unit testing, or stress testing, or end-to-end testing, or API testing. We hear stuff like this in front of testing all the time. But what we don't hear very much are words that evaluate the quality of testing, right? That are evaluative words. And when we sort these words out, what we get instead are words that refer to testing that's focused on a particular attribute or a particular relationship in the product. Or we think about stuff that's pointed at a particular interface, or test techniques, or maybe who does the testing, or what the context of the testing is. But we don't have a whole bunch of words, it seems, for the quality, or the extent, or the completeness of the testing. What comes to your mind when you think about those things? Well, we tried that experiment too. We tried that on ourselves. And what we came up with was stuff like this: structured or unstructured testing, complete testing, code coverage, repeatability, seen as something that sometimes people use when we talk about whether a test is good or bad. Or they talk about traceability, or they talk about rigor or professionalism. But notice how these words mischaracterize the notion of structure. People talk about testing that is experiential or exploratory or experimental in terms of unstructured testing, but it seems to be ridiculous, because there's structure to everything. Structure is the stuff that remains. The structure is stuff that persists over time. So notice how these mischaracterize what structure is, these first two things on the list. Then, complete testing. Well, complete testing is not possible in any kind of completest sense, right? We cannot possibly run every possible test that there is to run. It would take forever. Nobody would pay for it. 82% coverage. Well, when we're talking about code coverage, we're talking about the code that we wrote. We're not necessarily talking about the code that's in the product, because when we talk about code coverage, we're not referring to code that is in libraries or packages. We're not referring to code that's in the operating system or in the hardware. We're just referring to stuff that's on our machine. Test cases, counting test cases. You know, there's silly things that we do in software development, but counting test cases is one of the very silliest. How big is a test case? A test case is not a unit of measurement. A test case is a recipe for some activity for testing. Well, if you think about recipes for cooking, there are recipes for making instant pudding, and there are recipes for making consomme. There are recipes for making elaborate dishes that take 2 and 3 days to make. Well, the same is true of test cases. A test case is a recipe. A test case may investigate one condition or a whole ton of conditions. It may involve a step or two. It may involve dozens or hundreds of steps. So it's crazy, it seems to me, to count test cases. It makes a little more sense, it seems to me, to talk about time-consuming testing, effort. So, but even that is something that is by its nature imprecise, but we could describe it. We could says. And then a repeatable test or a traceability, that begs the question of whether it's worth it or not to repeat a test. If a test is traceable to requirements, well, that sounds like a good thing. But what about all the requirements that aren't made explicit, that we can still trace testing? So traceability, it seems to be a weird way of thinking about it. And then rigorous testing, professional testing. The question is getting vague. What constitutes rigorous or professional testing? So let's talk about what testers actually do. Testers, it seems to us, examine a bunch of things and we try to collect evidence whereby we could talk about facts about the product. So a fact to us is something that we treat as true regardless, or a fact is something that we treat as true rather based on evidence and based on inferences. Now, evidence is information that is relevant to saying is something true or false within some kind of system of reasoning. That's what evidence is. Inference, if we infer something, if we think of inference in its verb sense, that's a process of working from premises towards conclusions. If we know this, if we believe this to be true, then we can infer that that will be true. And inference is the outcome of that process. So, we can say by inference, we've examined these aspects of the product and we can make a claim that it's a good product. With some evidence to back it up. Or with at least a chain of reasoning by which we say, well, if this is so, and this is so, and this is so, then we can come to a reasonable conclusion that that is so as well. Assumptions and premises are interesting. An assumption is something that we treat as true, even though we don't have sufficient evidence or inference to call it a fact. So what we do is we say, well, let's act as though this were true. Let's assume that this is true and move on from there. A premise is either a fact or an assumption that begins a chain of reasoning such that we can apply inference and evidence and then get to actual fact. This is what we're doing, it seems to us, as testers. This is what we're doing when we're testing. Now, assumptions can be dangerous. Assumptions can be dangerous when they have consequences. And those consequences would result in harm or loss of damage. An assumption is dangerous when it's unlikely. It conflicts with other assumptions or other evidence that we've got. Assumptions are dangerous when they're blind, when there's no evidence for them whatsoever. Assumptions can be dangerous when they're controversial, when they conflict with assumptions or facts or evidence that other people have. So there's a sort of political aspect to the assumptions that we make as we test. And in fact, there are assumptions that are impolitic. That is, our social group expects us to declare the assumption, and by not doing that, we may violate social norms, we may be violating laws, right? The tobacco companies got into big trouble when they said, oh, we just assumed that everybody knew that smoking was dangerous. An assumption may change its state explosively, unexpectedly, and therefore the assumption can go invalid very quickly, or over a long time, an assumption can decay in terms of the support that we have, or the reasonableness of it. We might make an assumption too early. We don't need to make an assumption yet, and so an assumption can be premature. An assumption can cause us to go to sleep. For example, the assumption that because all of our automated checks are running green, everything's okay. And an assumption might be latent. That is, it might matter, but we haven't identified and dealt with it yet. Maybe bringing those things up to the surface and acknowledging that we're making an assumption can make that less critical or less risky. Okay, so given all those things, there are levels of assumptions that we make as we are thinking in terms of, say, the goodness of the product. A reckless assumption about the goodness of the product is one that's too risky to make regardless of how well it's managed. A risky assumption is one that could be wrong or that could cause trouble. But if we manage, if we manage those assumptions, then those assumptions might be okay. An assumption might be socially acceptable to make without any special management and without us declaring it, but they still might cause trouble. A required assumption in our lingo is one that is so safe that they cause trouble only when somebody declares it or tries to manage it. Well, let's unpack that. A reckless assumption is one that is often found in shaky premises, premises that could have a big impact on people, that are very unlikely or controversial, or just blind. Somebody who matters will judge somebody making a decision about assumptions like that harshly, because we don't want our assumptions and our beliefs about the product to be reckless. We want to help our clients avoid making those reckless assumptions. Because some people who matter might hold us to account, or might hold the decision maker to account, the decision maker being the client. We want the client to be well informed and to avoid making assumptions that are super risky and super dangerous. A risky assumption, not as bad as reckless, it could be wrong, or it could cause trouble. It might be unsustainable, it might be volatile, but when we weigh it against all the other things that we could be thinking about, that could be okay if we're aware of those assumptions and we manage them properly. So if as a tester we become alert to risky assumptions, it might be a good idea to declare it so that somebody can deal with it. They can monitor it, or they can manage it, or they can otherwise address it, right? They can speak up about it, get it changed. Some assumptions are safe. They're socially acceptable to make. They're not consequential, or if they're consequential, nope, no problem, because they're based on strong inferences, they're based on good evidence, they're based on facts. And you can make those kinds of assumptions without any special management or declaration. Nobody's going to give you grief for doing this. Your social group will forgive you. Whoever's making the judgment will say, well, if you got that wrong, well, things happen. And even though there's been trouble, we get it. We understand that at least you were being reasonable. That's how we would characterize a safe assumption. Now, there's one other category of assumptions which is kind of funny to think about, and that is a required assumption. That means that in the sense of somebody declaring this assumption, people will think that they're a little bit crazy if they do. Like, for example, if somebody comes over for dinner and they say, oh, yeah, come on in, feel welcome, by all means. Except I just want to make sure, I assume you know that it's not nice for guests to steal cutlery, or to take things from the houses that they're visiting without asking them. I assume that you know that, right? Well, people at that point, if you're lucky, they'll think you're joking. If you're not so lucky, they'll think you're insulting, or they'll think you're crazy. So, once again, to review: reckless, risky, safe, and required assumptions. Sometimes people say to testers, don't make assumptions, right? Testers shouldn't make assumptions. Well, we think that's crazy, because it's perfectly okay to make safe assumptions. And it's actually a little bit crazy to even mention that you're making required assumptions. And it's okay to make risky assumptions if we manage them properly. So, instead of saying don't make assumptions, let's say let's avoid reckless assumptions. Let's manage the risky ones. Let's not worry too much about the safe ones, and let's not be like strange or wild. Here's a key difference between testers and other people. Testers occasionally question safe assumptions that everybody else thought was safe. So let's get into what we're talking about when we're talking about testing. When we're testing, we are learning about the product. We're evaluating it by learning about it through experiencing, exploring, and experimenting. So, one way to think about what we're doing when we're testing is we're collecting and curating premises. We're checking safe assumptions. We're questioning risky assumptions. We're gathering evidence to support weak inferences and to support assumptions that might be risky or reckless. And we're challenging assumptions that other people believe to be facts about the goodness of the product. So we're challenging weak assumptions. That's really, really important. And we are challenging assumptions that might not be grounded in facts and reality, about the goodness of God. So let's think in terms of framing our testing and how we might dig up the question as a solution. When we're building a product, there's a kind of cycle wherein we discover something we think is worth building. We build some of it. We build it with change in mind. And then we study what we built. So those frames lead to 4 questions about the product. First of all, do we know how this thing should work? And in that frame of testing, we are developing the design, and we are developing our intentions for the product. And the kind of testing that we do in that frame is testing and review that can help us to discover what the customer really wants from the product. We try to figure that out. As we're developing our intentions about the product, we move to building some of the product in an Agile environment. Maybe we build just a tiny bit of it. More traditional environments, we build almost all of it. But as we're doing so, we're trying to build it cleanly and simply to answer the question, are we building what we think we're building? So in the discipline frame, that's what we call it. In the discipline frame, that's where we're doing review, pairing, shallow testing, automated checks, low-level, especially low-level checks, to help us discover if there are problems in what we're doing or whether what we're doing is reasonably close to what we intended to do. So that's a discipline frame of testing, and that frame is getting a lot of attention these days. As we talk about continuous integration and continuous delivery, what we're talking about is not really, is this a fabulous product, but what we're talking about is this the product that we think we're building? All right. As we move through the process of developing a product, we also need to think about preparing in 2 kinds of ways. Advocating for practical testability so that we can do this kind of discipline-related testing, and then organizing the project and the systems around it to afford us the possibility to test efficiently when it comes to this question right here. The question, do we know about every important bug? And that is the frame of testing that we call the realization frame. Now, the realization, when we say realization, it's a pun. Talking in 2 senses of realization. One is the sense of realizing our goals, achieving what we intended to achieve, making real the products that we're building. But there's another sense of realization too, and it's the kind, the sense of recognition, the realization that there's a problem in the product that we need to address. That is the frame in which we are going to perform deep testing. Testing that can help us to discover problems that are hidden to some degree, that are below the surface, that are subtle, that are rare, that don't happen all the time. They're intermittent or they're emergent. Problems that don't exist in any single component, but exist as we combine components and put them together. Or we've got a bunch of things that are working perfectly on their own, and then when we put them together, there's something about the way that they're put together that makes them not exactly do what we want them to do. Think of a product that has a bunch of well-tested components, but they don't quite hang together properly. So, in rapid software testing, there are these 4 frames for testing. And in the intention frame here, we're establishing quality criteria, we're getting together with diverse users and stakeholders, we're trying to specify the product with rich examples, we're doing reports from the field, we're collecting reports in the field and feeding them back into the process of intention, having learned something about the product, so that we can talk about the trade-offs between doing one thing and another, we can refine our user story. That's the kind of testing focused on developing the design. And that's the kind of testing, it seems to me, that lots of quality coaches these days. Now, the quality coaches, I think, have a point. They have an important point. It's good to get a testing-related mindset into the development of the design of the product. That's a good idea. That's a good idea. I'd like to honor that. And then there's another idea that goes along with that in the discipline frame, which is as we establish our intentions for the product, well, let's put in some low-level checks, some basic checks to make sure that the product that we're building is a product we think we're building, or to help us discover if it is. There are other dimensions to the discipline frame too, like sticking together to a shared coding style, refactoring the product for understanding and for maintainability, for investigating and fixing bugs as we go, for reviewing code, and for building and integrating frequently. That's how we'll find out if there are differences between the product that we intended to build and the product that we're building right now. As we move around through this landscape of development, one of the things that we need to think about is how we're going to prepare our infrastructure for testing, setting up the build pipelines, the automated checks within it, designing the product so it's intrinsically testable. So there's logging, scriptable interfaces, and there are hooks whereby we can probe the internals of the product to see how the product is processing stuff. APIs that aid with communicating with other products and with testing too. Doing testing in parallel with coding, so setting things up about the project so that we learn rapidly and we can get feedback loops back to the programmers quickly. Providing access to the product from all kinds of levels, from command line, from the API, from the graphical user interface the product has. Trying to keep things smooth, minimizing disruption. See, this kind of testing here in the lower right corner, this kind of testing, the key thing about it that's really important and really good about it is that it doesn't slow down development very much because it's not intended to be deep testing. So when we think in terms of designing how we're going to build the product and how we're going to test it, an important thing is to say, well, how can we help ourselves from stumbling into problems that surprise us later on? And that's a good thing to do in the discipline frame. But we also want to prevent ourselves from surprising us. When we start to do deep testing, we don't want to be surprised by things that happen at that point. So we foster testability so that as we build the product, as we build it cleanly and simply, as we foster testability, we prepare ourselves to do deep, experimental, imaginative, suspicious testing of the product, and putting harsher tests on it, deeper tests that are designed to find problems that are more hidden, more subtle. That is, I think, an area of testing right now which is suffering from a certain kind of vitamin deficiency. Our excitement about this kind of testing in the lower right corner is, I think, distracting us from the kind of testing that we do in order to find problems that surprise us, that are elusive, that are not easy to find with shallow tests, shallow checks, and that are focused on experience of the product, getting experience with the product. And I'm not just talking about user experience. I'm talking about experience at all kinds of levels of the product. Experience with the API, experience with putting the product to work in a rich environment where there's lots of data. Experience with developing and recognizing, realizing in that realization frame, new ideas about risks, ideas that we did not have at the outset. That's really important. It's really important to do that because our customer's experience with the product is going to be over a much longer haul than ours. And what we've got to do is we've got to get experience with the product so that we can avoid surprises, so that we can learn about the product deeply and rapidly. Now, there's a conundrum here because deep testing takes time. It's not something that we can do as cheaply and as quickly as this kind of testing down here in the lower right. It takes time and it takes effort to get to that point in just a second. Let me be clear, though, on what we mean by shallow and deep testing. Shallow testing is testing that has a chance of finding every easy bug. That's what shallow testing is. Shallow testing has a chance of finding every easy bug. Deep testing, by contrast, is testing that maximizes the chance of finding every elusive bug that matters, every bug that might get past. So how do we approach the notion of deep and shallow testing such that we can take advantage of those kinds of ideas? Let's go back to our levels of assumptions. And let's put them in a slightly different frame. Let's say we avoid testing shallow assumptions. We avoid testing reckless assumptions, and we avoid testing required assumptions. How come? Well, if an assumption is really reckless, we might want to start by avoiding testing conversation and replacing with a conversation, telling a story about a bug that affected other people that like this when somebody made a reckless assumption. Maybe we want to show an image, a thought experiment, like this. Maybe we want to show an image of, well, what happens when we've got little kids in dangerous waters? So we got a kid who says, hey, it's okay for kids to go swimming in there. Let's not do that. A thought experiment might highlight recklessness in a sufficiently dramatic way that we can avoid testing altogether. We don't need to do testing of reckless assumptions. We need to have a conversation instead. Required assumptions and safe assumptions and risky assumptions. How do we deal with those? Well, let's start with risky assumptions. For risky assumptions, deep testing could be a really good idea. Deep testing is important to let us find those hidden, subtle, rare, intermittent, emergent problems that matter. Good testing, where there's lots of risk, where we're dealing with stuff that is novel, or whether there are things on the line, whether there's money, health, human safety, reputation, where those things are important. Deep testing is probably what we want to do in order to find problems that might have escaped us early on, doing responsibly deep testing. So that's the image we've got there. We get down, we might need special equipment to do it. We might need a crew of people. We might need lots of support from above, and that's what's happening in this circumstance. We want to understand something where there's risk. It's a good idea to have lots of gear, lots of help, lots of support. This is a thing that deep testing requires commitment. It requires knowledge, skills, tools, equipment, team support. And here's something else it requires. It requires determination. It requires a commitment to doing it. That's what's really important. What about...
We do have a question. We do have a question.
Sure, go ahead.
This is from Prashant. So this is testability, automability are often overlooked. How can testers ensure that testability is not an afterthought and is considered right from start of development?
Well, that's a great question. And I think the answer is that we have to talk about it. We have to learn about talking about it. And the way we talk about it, it seems to me, is that we tell a story of our testing. So let me put that question on hold for just one moment, and we'll talk about that part of testing, that dynamic in testing, because I think it is really super important for testers to do that. But in order to do it, we have to learn to tell stories of our testing. So I'll come back to that point. It's a great question. I'm glad you asked it. For safe assumptions, it's okay to do shallow testing, right? Probably more reasonable, less expensive, less time consuming. And if we're working pretty close to the surface, well, we have some tools that can be valuable to that. But those the problems that we see are not going to be too threatening. Good testing in safe situations is justifiably shallow. And one safe situation is, as we're building the product, well, it's all right if there's a little mistake that's being made, if there's a problem that's close to the surface, it's easy to spot, no worries, we can get it fixed. And we can discover that the product that we're building isn't quite what we thought, and we can get those things fixed quickly and cheaply and easily. We don't need a whole ton of formality. We don't need to go particularly deep in order to see those kinds of things. Now, on the other hand, as testers, we got to be prepared to test more deeply than builders. to challenge the assumptions that everybody else believes that are safe. Because when we're doing deeper testing, what we might find out is assumptions that everybody thought were safe were actually not very safe. So, what about the required assumptions? Well, things that fall under required assumptions probably aren't worth testing either. If you talk about them, or if you even talk about testing, if you test them or even talk about testing, it's likely that somebody is going to say, that person is not very thoughtful as a tester, not very skilled, or is obsessive compulsive about a certain thing and isn't focusing properly on risk. If we are in a risky situation, that is when it's really important to do good, deep testing. But if we're doing something where there's no risk, in particular, and it's likely that somebody is going to get upset with you for being overly precise or crazy. So to answer Prashant's question, here's what I would suggest. Testing is telling three stories that wrap around each other like a braid. We're telling a story about the status of the product, what it is, what it does, how it fails, how it might fail in ways that might matter to our various clients. And that, it seems to me, is a story mostly about bugs, problems in the product or risks in the product that we're discovering as we're exploring and experimenting and gaining experience with the product. We also need, I think, to be prepared to tell a story about how we tested, how we configured and operated and observed and evaluated the product, how we recognized problems as problems, and how we recognized how significant they were. Prashant, when you're talking about how to prepare for deep testing and how to get ourselves onto the table for deep testing, we've also got to talk about coverage. How we covered the product we tested. And that's a story about what we've tested so far, what we haven't tested yet, and what we won't be able to test at all unless something changes. So important testing not yet done has to be a story, a part of our story as testers. In terms of getting attention on testability early in the project, it seems to me that an important way of doing that is to tell a continuing story about the quality of the testing, a story about how good the testing is, how good it was or how good it could be, and what's getting in the way of testing, what's making testing harder or slower or less valuable. Because if the product isn't sufficiently tested, if the product is not sufficiently easy or quick to test, then we've got to get that in front of our clients, and we do that by telling the testing story of them. And here's a way I've got of illustrating that, I think, which might help a little bit. If I look around the web, I see this vitamin deficiency over and over again. This attention that's being paid to what I think is really fairly shallow checking. This, it seems to me, is the best tested part of any software system out there. People go crazy testing this stuff. You see this over and over again. Can we log in? Can we log in? Can we log in? And maybe the people are doing more than that, but they're certainly talking about this a lot. When I encounter my client, one of the things I want to put in front of them is what there is available to be tested. And here is what I came up with after an hour or so worth of brainstorming and a study of the landscape. That, what do we got? That an authorized user won't be able to log in. That there's all these kinds of quality criteria that we can examine. An unauthorized user might be able to log in. An authorized user might be able to log in and not get what he or she wants. There could be cross-site scripting issues involved. There could be access using a bunch of different user roles and authorizations and so on. And then I got to ask myself, as I'm testing, what kind of testing is needed? Are there lockout warnings that we need to evaluate when we're testing a login thing? the password as acceptable and unacceptable characters. What happens when people put unacceptable characters in? What happens about the characters that are accessible or that are permitted, but they need to be escaped if they're going to go over HTTP? What if we're testing for unacceptable characters? We're going to have to test them one at a time, because if we test them all as a group, one character will prevent us from getting our stuff accepted and one won't. So the others won't. We might miss some of the important ones by doing that. What I'm showing you in this very quick and very brutal way is ways in which we could describe and think about deep testing by mapping it out. Instead of saying, let's check a single condition, let's look at all the different things that we could test. Now, very quickly to wrap up, because I know I'm running out of time, when I compare that line of code that I showed you, you're now successfully logged in, to this whole landscape of stuff, this whole coverage map, and believe you me, this is not all there is to it. This is 1 hour of brainstorming and 1 hour of looking on the web at stuff that I thought might be relative to logging in. This is what we need to get in front of our clients to advocate for testability. Because how do you get deep? Here's how you do it. You got to be determined to do deep testing. We can't just stumble into it. We got to want it. We need skills. We need to have skilled testers. And that's an aspect of testability too. Subjective testability. Knowing how to model products, to design experiments to evaluate them, to develop the tools that we need to develop. We need rich and detailed models of the product and its context and of testing. They might be mental models, they might be formal models. And deep learning about the product requires learning about it and how people use it, and that requires experience with it. So there's a crossover, value-related and epistemic testability. Epistemic testability is how big the risk gap is, the gap between what we know and what we need to know. And we might need tooling to help us get over large areas or cover hard-to-access areas of the product. We might need intrinsic testability built into the product. And in order to do that, we need project-related testability in the form of team support and of management support. Developers can help us a lot with that, and we need time. Coordinating all this and performing deep experiments needs time. And one way to get that time is to say we're not going to try to do deep testing on every build. We're going to do deep testing on periodic builds. Every few builds, we will reserve some time to do deep testing and explore that, and we'll trust the discipline-related testing in order to help us prevent big surprises in the realization. We need variety in our models, too. We need to add variety in all these different dimensions of risk, of coverage, of data, environments, of activities and procedures and test techniques, operating the product to find obscure bugs, bugs that aren't easy to find, bugs that are elusive. And we need lots of different dimensions of quality criteria to identify different ways in which people might have their value of the product threatened. So that is how we think about deep and shallow testing, and we can replace it with a kind of slogan here. Deep is not necessarily an insult, or shallow rather, is not necessarily an insult because we need to go through shallow testing to get to deep testing. And deep is not necessarily a compliment. Testing might be excessively deep when it's not necessary. So here's our little prescription for this. Let's try to make shallow testing deeper, and let's try to make deep testing cheaper. So how do we characterize good and bad testing? To go back to the question we raised at the beginning, maybe let's talk in terms of responsibly deep testing as good, and obsessively deep testing is not so good. Recklessly shallow testing is probably not what we want, but we have to go through shallow testing to get to deep testing. And shallow testing is useful for finding those easy-to-find bugs that could be more expensive to encounter later on. Justifiably shallow testing is okay. Inexpensively deep testing is wonderful, but wastefully deep testing probably not so much. Efficiently shallow testing, okay, but ponderously shallow testing, the kind of testing that we do when we try to get humans to walk through mechanistic, algorithmic kinds of recipes for testing, that doesn't seem to be very worthwhile. Let's use tools to accelerate that sort of stuff. And let's use tools in ways that will help us to not just check the product for things that are checkable, but to help us explore and investigate, generate the kind of data, generate the kind of visualizations that will allow us to understand the product. And that, dear friends, is the talk for today. There's a bunch of other references that I could refer to, but let me offer those in the comments, and instead what I'll do is I will simply say, this is how, whoops, come on, just one. This is how you get in touch with me and with James if you've got questions about this, and I'm happy to answer questions now if there's time, or if you like, I can answer questions in the chat, or you can contact us online. Up to you.
Yeah, we have one last question, Michael. So this is from Faisal. So
Yeah.
he's asking, can you comment on business practices such as those in startups whose intrinsic focus on velocity and a push to get MVP into customer hands very naturally promotes shallow testing over deep? Executive decisions do favor a push for automation over rigorous exploratory testing, and this is out of the hands of QA.
Well, no, it's not out of the hands of testing. I think that's, I disagree. I'm sorry, I disagree. As testers, we have a responsibility to our clients, and that responsibility includes identifying risks and asking if the client is willing to take those risks. And if the client is willing to take those risks, that's okay. But for us simply to lie back and say, oh, well, we'll just do what the client wants, you've got a choice as a tester, it seems to me. And my colleague James Bach puts this really wonderfully. If you've got a choice between being a doctor or a drug dealer. You know the difference between being a doctor and a drug dealer? A drug dealer believes in customer satisfaction, and a doctor believes in customer service. It does not serve our clients very well to have them run blindly forward in terms of risk. If we are going to be responsible testers, it seems to me we must put that question in front of in front of management and say, here's the kind of testing we can do. We can do deep testing, or we can just perform a bunch of automated checks. If we perform a bunch of automated checks, and if you're focused on that, listen, that's a good thing. It's a good thing to detect easy problems. It's a good thing to detect easy problems. But I want to, as a tester, to remind you, that there are problems that the automated checks are going to miss. Guaranteed. And those are the problems that we're not going to find by automated checks. We need to gain experience with the product. Now, if you're okay with us missing those problems, if you're okay with those problems causing harm or loss or diminished value to our customers, our clients later on, that's all right with me. I'm not the manager of the project. I want you to be aware, dear client, I want you to be aware that those problems will escape us, and they could be a lot bigger problems than you have in your imagination of what would constitute a problem for the business. The thing is that deep problems often destroy the value. So it seems to me if there is loss, harm, diminished value, the possibility of risk that is a company ending or a reputation destroying kind of event, it seems to me that deep testing would be an awfully good idea. But dear client, if you don't want that, that's all right. I just want you to be aware of this.
Awesome. Well, thank you so much, Michael. That was really good. And well, what was that quote again? So, difference between doctors and drug dealers?
Yes, a doctor believes in customer service. A drug dealer only believes in customer satisfaction, which is I'll give you what you want and damn the consequences. But a doctor will remind you of the consequences of a particular therapy or a particular drug.
Mm-hmm. That's very true. So, Michael, yeah, time's up right now. It looks like that was a really good That was a really good presentation. So if you guys have any further questions, feel free to submit it in the chat or even in the Q&A tab, and keep the discussions going. So this is really good. This is what it's really all about for the community.
I submitted some references in the chat window as well for people who are.
Okay, for sure. And even after this as well, Michael, you could send it my way or to Srija, and then we could share it with post event when we share.
Stick around for the next presentation. We can maybe have some questions or discussions later if there's time for that.
Yeah,
I'll
for
turn
sure.
on my video now, but I'll still be around for the rest of the session as I think.
Okay, sounds good. Thank you so much, Michael. And next, I'm gonna bring up Sneha Viswalingam, and she's a staff test automation engineer at ZOLL LifeVest in Pittsburgh. She started her career in the field of test automation in Silicon Valley, where she got opportunities to learn and grow in the field of QA. Her interest lies in topics like continuous testing, testing in machine learning projects, software operations, test and infrastructure automations, agile, regulatory. She likes to blog, speak at tech conferences, and create videos related to testing and professional development. She also teaches high school kids how to code through the Microsoft TO's K-12 program. So right now I'd like to bring up Sneha. You could go ahead and share your screen as well. I'll turn off mine.
Thanks, Tim, for that amazing introduction. Can you see my screen?
I can.
Awesome. So welcome everyone, and thanks, Michael, for that amazing presentation. It was really good. And welcome everyone to this talk on managing distributed test infrastructure using Selenium Grid, Terraform, and AWS. And before we move on to this, I just want to get a quick, show of hands on how many of you have, wait, before I go to that, how do I see that? Just a second. So I have a list of the participant view over here. So how many of you run your test automation in a nightly scheduled build kind of infrastructure? Can you raise your hands in the participant chat, like in the participant view? Okay, I see 2 hands. Awesome. Now, if you can clear that, the next question is, how many of you have more of a continuous testing and DevOps approach with continuous testing in place with using infrastructure as code and some things like that? Awesome. I have so many hands up. Cool. Thank you so much for that. Now you can clear that. Cool. So, at this point, with DevOps and continuous testing really modernizing the way we release software, it's more important to have more test coverage to make important decisions with faster feedback. So to design that kind of solution that supports that, we need a scalable, manageable, and cost-effective, most of all, kind of infrastructure. So in this talk, we're going to discuss a little more on that topic. Tim already introduced me, but if you'd like to get in touch with me, the best way would be on Twitter or LinkedIn. I also blog on my website. It's called snehaviswalingam.website. And I just started creating some YouTube videos on, talking about software testing and professional development stuff a little bit here and there. So today, in today's talk, we're going to start with talking about the evolution of test infrastructure. And then we're going to talk a little bit about infrastructure as code, understanding infrastructure orchestration tools and understanding configuration management tools, and then a little bit about that distributed test infrastructure workflow. So to start with the evolution of distributed test infrastructure. Back in the days, it was easy for anyone to just spin up the Selenium server on a spare machine under the desk and call it a day. But now, times are changing and there are so many moving parts and that all need to be really effectively managed. So let's take a look at how the evolution of test infrastructure has been since the beginning of the introduction of UI automation using Selenium. So first, in the beginning, when it was just introduced, it was basic test automation execution as and when it was needed, sometimes even in the person's laptop, right? Then, because at that time, the focus was actually on just automating, like adding some automated checks to avoid repeatable tests to reduce the testing time. So the attention was not so much on the infrastructure, but the approach was very naive, and we probably used to automate the tests, and we ran them as and when needed to speed up the testing process as such. And then we started going into the executing test automation in the nightly scheduled builds with an intention to get a report when we come back next day to work to see the health of the builds of the previous day, right? So it was mainly just for us to get to understand if something broke in the previous day's builds. So as the number of tests kept increasing, we started to have a need for distributed testing. So the need for distributed testing arises when you have a lot of tests to execute in a limited amount of time, and then you have to test the application in different browsers and different OSs at the same time parallelly, and then you want to reduce some time execution so that they can be run frequently or to be triggered or even after merge requests or any changes to the repository that's being made. So with the need for distributed testing, and around that time we had the introduction of Selenium Grid, which really allows the execution of WebDriver scripts on remote machines by both virtual or real remote machines by routing the commands sent by the client to the remote browser instances, right? So it solved a subset of common delegation and distribution problems, but it does not, for example, manage our infrastructure and things like that. So one still had to update the drivers in the browsers in the nodes, and we had to take care of the maintenance ourselves. So at that time, around that time was so then we started executing the test execution with Selenium Grid. So there are more than one way to do this, right? So many organizations would immediately start thinking about creating a lab managed on premises or in the cloud with virtual machines. So this approach actually worked well in many places, but for other organizations, this may have been more of cost prohibitive approach, or it was slow to spin up, or it was difficult to maintain. So these were like some of the pain points that came along with the introduction of Selenium Grid. So around that time was also the introduction of different SaaS solutions. So many companies like Sauce Labs, Browser Stack, and Lambda Test. And if I didn't mention any of your favorite services, please don't be mad at me. These are just some examples. So luckily, at that time, these were introduced to tackle that kind of problems. These were mostly like cloud-based services, which kind of provides environments for testing with Selenium, Appium, and sometimes even gives some manual execution, some space for even manual execution in their cloud. So with these, you got all the combination of environments with versions and browsers and devices that one needed for testing. So for companies that had highly confidential data like HIPAA constraints and banking related information, they had options for having secure connection that made it a very viable option for them. But obviously that also came with some cons, which could be related to cost, since there's amazing customer support and there's no maintenance required from our end. It came with the cost, and as the tests keep increasing, the cost could considerably increase as well. So and moving into the cloud also started to look like a very attractive option for people, because migrating an in-house Selenium Grid to the cloud makes automated testing of web applications independent of the physical infrastructure. So this kind of eliminates the need to purchase and maintain devices to test them on. So Selenium Cloud also provides like high availability, which reduces the risk of downtime. So moving to the cloud was becoming a very trendy thing, and a lot of people were looking at options to move to the cloud. And that gave rise to a lot of DIY solutions for people to, like, architects were coming up with their own solutions if they didn't go with the choice of buying an off-the-rack solution to run their test in the cloud. And then came, the rise of DevOps culture and continuous testing and the modernization of the cloud infrastructure. So at this point, one of the steps for DevOps to be really successful became adding continuous testing to their pipeline, because continuous testing would mean that you're testing often, testing everything, and testing throughout the pipeline. So this also means that we need a scalable test infrastructure, which is also cost efficient and reliable. Because if this is not taken care of, if continuous testing is really causing a bottleneck by not being very efficient, and people may sometimes lose patience if your testing stage is taking so much time to give feedback and to give results. That's really going to slow down the entire pipeline, and people are going to lose patience. So we don't want testing to be a bottleneck in the process, right? So that is one time when infrastructure as code, the introduction of infrastructure as code in the continuous testing world was really something that was super cool, I think. And now what is infrastructure as code, right? It's the process of provisioning infrastructure using code without any manual intervention that can be versioned and tracked using source control. So it is basically writing your infrastructure as code. And that really helped, and that really helped having a sophisticated test environment that is needed for continuous testing. So when we talk about some of the infrastructure as code tools, some tools that come to mind are tools like Terraform, CloudFormation, Heat, Ansible, SaltStack, Chef, Puppet, and others, right? Now while we work with them, it's important for us to understand the difference between infrastructure orchestration tool and configuration management tool. Now, what is infrastructure orchestration tool? So these are tools that can actually provision the servers and infrastructure by themselves. Like, for example, if you're using AWS, right? The tools that can actually help to provision EC2 instances in AWS, right? Those are the infrastructure orchestration tools. And some examples of such tools are Terraform and CloudFormation, because these actually help us to build the servers themselves. Whereas the configuration management tools, now these are the tools that are designed to install and manage software on an existing server. So what that means is if you already have an EC2 instance in your AWS, then a configuration management tool will help you install and configure whatever application or software you want within that already existing EC2 instance. So that is more of a configuration management tool. Now, tools like Ansible, Chef, and Puppet, these are all examples of configuration management. Now, while using these two tools, it's important to understand that some configuration management tools can also do some level of infrastructure orchestration. For example, Ansible can help in also creating EC2 instances in AWS. But some of the best practices when it comes to DevOps is to use the right tool for the task. So if a tool is known for configuration management, it's best practice to use that only for configuration management. And if a tool is best used for infrastructure provisioning, then it's best to stick to that and use it for that. And you can use a combination of both of them in the system to realize whatever we want to fulfill. So the next thing is about choosing the infrastructure as code tool. So when we want to choose our tool, what is some of the questions that we have to ask when we decide which tool is the best for us, right? Now, the first question to ask will be, is our organization, does our organization have a long-term vendor-specific infrastructure? Like, for example, I can give you an example of, suppose your company is completely using AWS and they've decided that this is the approach that they're going to take and this is what they're going to do. So maybe using a tool like CloudFormation, which is specific to only AWS, would be a good option for you. And the next question would be, is it a multi-cloud or hybrid cloud-based infrastructure? So if you know that your company uses 2-3 different clouds, for example, if you use AWS, Azure, GCP, you have so many different clouds that you're going to be using, or maybe you're not, maybe you're using only AWS now, but you have future plans to use different clouds. So if you want to keep that option open, then you would use something like Terraform, which is a multi-cloud, which is more of a hybrid cloud solution. And then if you need to integrate with configuration management tools, so some tools integrate better with other certain kind of configuration management tools. So if you know that you have a certain configuration management tool that you want to use, then these are some questions that you can ask to really decide which tool to choose for your organization for the solution that you are coming up with. And then the cost is definitely a major factor for anyone while choosing a tool. And the customer support as well is an important factor while trying to understand which tool to choose. So talking about this, right, let me quickly show you how the different tools work like. So this is an example of cloud formation, right? So if you are going to be mostly in an AWS based environment, cloud formation also, like these are tools that the companies really make the tools very easy to use. For example, if you want to provision an EC2 instance, you can just drag and drop and it automatically creates the code over here. And then if you see Terraform over here, Terraform has so many different providers. It has like so many different providers and tools that it has integration with, which is why it's more preferred for a multi-cloud or hybrid-based infrastructure. If you see, it has it goes with GitLab and GCP and OpenStack, and there's so many different options available over here. And it's easy to learn as well. If you go to the learn section of it, they actually show you all the different ways that you can get started with the cloud that you are interested in. And then the documentation is pretty good in the Terraform website itself. Next, let's talk a little bit about Terraform. So Terraform is, again, we mentioned that, Terraform supports multiple platforms. It has hundreds of providers, and the configuration language is pretty simple to use. There's not a very deep learning curve in trying to learn the language. And it has very easy integration with config management tools like Ansible. And it's also easily extendable with the help of plugins. If you see the website, they have a number of plugin options as well that's mentioned that really works well with Terraform. So the next thing that we want to see is, kind of trying to understand how all of this fits together. Now, for example, right, let's take these basic steps that we want to do. So the first thing, we want the Jenkins to really trigger the build, and then we want to create an EC2 instance, and then we want to install and configure Selenium Grid into that EC2 instance, and then we want to return that IP address of the instance to feed it to the test suites, because that's going to be the IP address of the grid, right? So that has to be fed to the test suite so that the test can go and run the test can run over there in that using that Selenium Grid IP address. And then after the test is run, we want to destroy the EC2 instance. Okay, so this is kind of the process that we are interested in, that we are looking at. So let's take a look at how that really looks in the workflow point of view. So over here on the left hand side, you have the Terraform config file, which has information to go and create an EC2 instance in AWS and install and configure Selenium Grid inside that instance, right? So once you apply it via the Terraform, right, it will interact with the backend provider. In this case, the backend provider is AWS. So it goes in and it asks it to go create a new EC2 instance, creates the EC2 instance inside AWS, right? And then depending upon that, a new EC2 instance will be created. And once it creates, the message is returned back to Terraform, and it gives Terraform the IP address. Okay, I created an EC2 instance. Here is my IP address. Take it. Now, Terraform integrates really well with configuration management tools like Ansible, like we mentioned before. So Terraform will now take that IP address and give it to Ansible, and it'll ask Ansible to go ahead and install and configure Selenium grid, whatever method we're using, to go and configure it within the EC2 instance. So now after all of this is done, Terraform will send the message back that, all things that you define in your configuration file are now completed. So, this is like the basic workflow that we are trying to accomplish in the pipeline, right? So when we want to run our tests, we want to create an instance, and then we want to create our Selenium grid, and then we want to run our test, and then we want to destroy the instance that we created. So that way we are making it very efficient and less cost, because the instance is not always on. We're just creating it and destroying it as and when required. So we're only paying for what we're using. So the next level, right? This is just to reiterate, right? So first the Jenkins creates it, Terraform apply, and then Terraform creates the EC2 instance, and Ansible installs it, and then it sends the IP address to the test suite, and then it destroys. So here we can see that, infrastructure itself was created as code. It was so easy for us. We didn't have someone to go in manually and, configure all the different things. And we didn't have to put in an IT ticket and wait for IT to get back to us. And, we just went ahead, we added it in the pipeline, and we source control the code. So it's described, even if someone else is coming to the team, and if they want to take a look, it's all there in the code. So it just makes the entire process so efficient and so easy, and so well executed as well. Now these are just examples of the different combinations that we've used, but one can get very creative and use all the different number of different tools that's available according to the needs of the team, right? So these are all DIY custom options which we will configure according to what is required for our team. You could have auto scaling, you can have so many other options according to the number of tests you have and according to the number of environments you have. So yeah, you can take it from there. Now that brings us kind of to the end of this talk on, to summarize what we looked at. Using infrastructure as code really makes infrastructure more reliable and scalable, and it actually gives an opportunity for developers and testers to create an environment as and when needed, to even test features in isolation if they have to. And then the code that describes the infrastructure is version controlled, and the code is integrated in the CI/CD pipeline itself, and it happens in a fraction of a second. And it doesn't really become a bottleneck in the testing process. Testing should never be a bottleneck in the pipeline. That is really our aim, to make that process as smooth as possible, at least from the infrastructure point of view. Now, how we add, what kind of test cases we add in continuous testing, that is a completely different topic. But at least from the infrastructure point of view, we don't want any bottlenecks to be caused, right? Infrastructure shouldn't take time to spin up. Like it shouldn't take like 5 minutes to spin up and then 10 minutes to set up something. It should all happen within seconds, so that the process is as quick and efficient as possible. And then the next step to make continuous testing more efficient would be on the choice of the test cases that we add based on the business risks and things like that. So and this also considerably reduces the infrastructure costs. So that is also another reason why adding infrastructure as code really has given to the evolution of test infrastructure. So that is all I had. Thank you so much for being a wonderful audience. And if you have any questions, feel free to ask.
Yeah, there's one question from Faisal. So he's asking, can you provide any specific benefits of using Terraform over Ansible? Some shops seem to use Ansible for instance creation in what seems like an overlap of functionality.
Yes, yeah. So I did see that even Ansible documentation has documentation on how to create EC2 instances. Yes, a lot of companies use Ansible in place of Terraform, but what was the question again? Why? Wait, let me read the question.
Oh, yeah. So can you provide any specific benefits of using Terraform over Ansible? And just talks about Ansible. Shop seems to use Ansible for instance creation in what seems like an overlap of functionality.
Functionality. Yeah, it does. Yeah. So Terraform was built specifically for infrastructure orchestration. Now Ansible does both configuration management and a little bit of infrastructure management. So the one of the best practices would be to just stick to what the tool is built for, and not we can be like I would say that configuration management and infrastructure orchestration are very good friends. Like they really go hand in hand. That is why we can see how beautifully it really takes from creating an AWS instance and then using them for the actual configuration part of it. It's just one of the best practices to stick to what the tool is built for. But you're right. There are so many companies that actually use only Ansible. If it works for them, it works for them.
And then one more from Faisal as well. Is it worth looking into Kubernetes? I'm not sure how to say that. Kubernetes.
Yeah, Kubernetes or Docker Swarm. Yeah, it's definitely worth looking into those options as well. In this talk, I was just focusing on this. I was not going deeply into what is it that we are using over there. But yeah, it is worth looking into those two as well.
Okay, sounds good. And we have some anonymous people in here, so please be respectful. Especially in terms of this. This is for in terms of community, and we're trying to help each other out. So, and yes, I am a noob in terms of QA, so I'm here as a host. So, but thank you so much for that, Sneha. That was really good. So.
Thank you, Tim. It was nice. It was nice meeting you and everyone here. Thank you.
Yeah, if there's any further questions, we'll still keep this active a little bit, and if you have any questions, we can use this as a forum. So, yeah. So thank you so much, Sneha. So as I mentioned, I am from DCCAP, and DCCAP we're a e-commerce, we're a digital agency. So these are some of the other products that we do have. So QA Touch is the QA test management that we have, and then we also have Productomize. It's a product configurator showing real-time customizations on e-commerce websites. And then we're also doing a lot in regards to B2B. So Chorus is our ERP integration that will integrate it with Magento or BigCommerce or Shopify Plus. And then our latest product is FlexiPIM. So it's a product information management system. So if you guys have any questions in regards to that, feel free to reach out. So these are some of the products that we have. And then just a final note. So, mark your calendars on August 17th. We do have the next virtual series. So this will be number 4. So hopefully you guys enjoyed this series today. Post this event, we'll share with you all the videos and all the content information from Michael and from Sneha. But until then, you guys have a good one. Stay safe out there, and we'll see you next time.